Hi, now look at this at these two examples on circular motion. If we have a string and a mass in that string, and this mass is rotating in with velocity v, the radius is capital R. We have f radial or central, and we have also time period for total or full rotation, which is capital T. As we know, the acceleration is equal to v squared over r, and the force is ma, which is mv squared over r. It is Newton's second law. If we have r known is given, which is half. If we have the velocity is given is 3. If we have the mass is given. From r and velocity we can compute the acceleration. With the existence of the mass we can find the force. For example, the acceleration is v squared over r, v3 squared 9, r half. 9 over half is 18 meter per square second. What about the force? The force, we need to multiply just the acceleration by the mass. It will be 1.8 newtons. This is the F radial. This is another example. If we have a planet, a satellite rotating out around this planet, and the radius of rotation is 150 kilometers from the center of that planet, not from the surface. Okay? If the mass of the planet is given and the mass of the satellite is given, it is just like a car mass. And the period of rotation is 5 hours. So the full rotation during 5 hours. We need to compute it in seconds. So I will convert hours to seconds. So I have 5 hours. I will convert it to minutes, which is every 60 minutes are 1 hour. And every 1 minute is 60 seconds. Then the time period is equal to 5 multiplied by 60 by 60, which is 5 multiplied by 3,600, which is 18,000 seconds. This is the time. We can compute the acceleration by v squared over r. V is the speed rotating this circle. The circumference, which is 2 by r over t. T is the total time period, is the velocity. We need to square it. So we have another relation for the acceleration, which is 4 pi squared r over t squared. We have all of these parameters are given. We just need to put them in the equation, and we find that the acceleration is 0.0183 meter per square second. What about the force? We just need to multiply the mass, which is 5,000, by this acceleration. Then we find the radial force, which is 91.39 in newtons. It is small, 91 newtons. To know that this mass is small, this force is small, the weight of this mass on the ground is almost 50,000 newtons. So when we compare the weight outside in the space with the weight on surface, we can say it is weightless. We don't have gravity. No, we have gravity, but this gravity is very small compared to the gravity on Earth surface or on a planet surface.